So next up, we've got Paolo, who's going to start coming to the stage. But during that last talk, there was a lot of talk about benchmarking and data. So I thought I'll do a little bit of data mining on the speakers today. And over 60% of this morning's speakers are Node Core contributors. And I know some of you out there going, oh, God, I wish I was one of those as well. So this afternoon, Paolo and some of the team from NearForm are going to be doing a workshop where you can do your first Node Core contribution. Yep. So, yeah, here you go.
Yep, just come. Don't miss it.
So,
just see.
Hello, Paolo. How are you doing this morning?
All good.
All good. Are you all ready?
I guess so. I can't see here, but
yes.
I guess so. Yeah.
So this is Paolo from NearForm. He's wearing a cat T-shirt. He's very passionate about cats and code. So, are you ready to go?
Yep, absolutely.
On you go. Give it up for Paolo.
Thank you, Fox. So, since we just talked about URL parsing, let's move on with HTTP parsing, right? So, being reckless sometimes pays off. That's the bold sentence to catch you all. Like I say, I'm Paolo. Briefly introduce myself. I'm a Node Core Member like pretty much everyone else today, so doesn't matter. Staff DX engineer at NearForm. I come from this little tiny dot in Italy. There are just few Italians here. I could ask where I come from, but they know where I come from, so it doesn't matter. For knowledge of the rest of the world, the rest of Italy does not acknowledge the existence of our region. They joke with us, say, you don't exist, you're useless, whatever. I mean, anyway, you can find me online on these handles over there. I just redesigned my website, so if you can give me some feedback, that would be much appreciated. We also know that we all already know about NearForm. We are 400 and counting, professional services company. The core idea here is that we are hiring. So if you're interested, just go to Amy or other people from the talent team from NearForm and just chat with them. Let's get to the meat. We all love HTTP, right? That's used everywhere for anything. So, we love it. We just have to decide which HTTP are we. There are several versions, right, of several possible usage of HTTP. Surprisingly, HTTP is more than 30 years old. HTTP 0.9 was actually drafted in 1991. So it's probably older than many of you. Unfortunately, not me, but many of you. The HTTP 1.1 was the last version of the initial version, of the protocol, and is by far the most famous and most used. Especially because, for instance, within your data center, you usually don't use HTTP2 when you use something as a reverse proxy, you go by HTTP 1.1. If you do, don't forget about keep alive, it will save your life. Remember that. Otherwise, you have HTTP2, which was developed out of PD to remove some problems of the original HTTP, because the TCP connection was not really well used and was very congested. So they tried to say, okay, let's do something else. I would say kinda not a successful attempt. That's why we have HTTP3, which is a revolution because after so many years, since everybody settled on TCP, let's use UDP, right? So we have quick UDP, HTTP3, which is going to solve a lot of problems eventually. And what about Node.js? In Node.js, we have HTTP1 and we have HTTP2 from several years. I'm talking decades, a decade in case of HTTP1, and they are stable. You can use it every day. You will be fine, except for bugs, which usually I fix. So anyway, if you find it, just report it. For HTTP3, work is in progress. There are people that are patiently developing the quick implementation, hi James, and then there is the protocol stuff that we still need to figure out, but we are working on that, so it's going to come soon. No responsibility for soon. But here, we can't focus on all the implementation, so we just focus on one of them, which is 1.1, because by far is the most important, right? What is the situation in Node for HTTP parsing? The current parser is llhttp. It was written by Fedor Indutny, in 2019, And the current parser and the default parser is Node 12. Like I put this straight out. llhttp is just very, very great. How it works is a state-based HTTP parser, which is based on another library, which is llparse. And now the things get interesting, because llparse is a library capable of generating a state-based and performant parser from a definition in TypeScript to C. So we are talking about transpiling TypeScript to C. And if you're wondering why, the reply is probably why not? It's possible, let's just do that. But there are problems with this implementation. First of all, as you might figure, it's hard to debug and release, because transpilation makes it hard, because it's nearly impossible to link your original TypeScript definition to the generated code. Find those references is very, very hard. I mean, I know, because currently I'm pretty much the only maintainer of llhttp. I haven't wrote it originally. You have no idea. Lucky for you. Also, llhttp was written several years ago. It was not even HTTP 3. And it supports HTTP 1.0, HTTP 1.1, even HTTP 0.9, and HTTP 2, I mean, when you decode it. The problem is that, why? Because the HTTP 0.9 and 1.0 haven't been obsoleted for the last, 20 years. So why do we even support them yet? Also, as I just said here, this is a common Italian sentence. So you say, you give them the finger, they take your arm. Basically, right? LHTTP is based on a leniency-prone approach, where basically you can specify several leniency flags, which usually are enabled by default in many cases. And in that case, you accept non-conformant clients or servers. And it's a problem, because basically this approach opens the doors for, first of all, edge cases which usually should not happen, and also for a lot of vulnerabilities. I get continuous reports on vulnerabilities because people enable these leniency flags, or they want this thing enabled, and they don't know that even if they get the beloved leniency flag, they might be exposed to vulnerability. And in that case, we're not going to fix it, because it's not actually a problem on Node or the parser, but on how you use the parser on your specific application. So generally, it's a bad idea. Which comes to, do we have a solution? Raise your hand if you think that I actually have a solution today. You don't have trust in me. Thank you very much. Anyway, let's move on. Yes, the solution is that we start fresh. The llhttp is unmaintainable as we speak, because it was also lacking any documentation, so it was impossible to understand how the transpiler worked. I tried to look into the code and I got lost. I received a PR a few days ago, and I got lost even in the PR. I got lost, so just in the code, just the PR itself is very hard to debug. So I say, I'm done. Let's do something else. Which means I ask you to say hello to Milo, which I hope is going to be the new HTTP parser for Node.js. Why is it named Milo? This guy was actually Milo. He was a Tamia, or a Japanese squirrel, that my wife had several years ago. And nowadays, unlike Yagis that named after his daughter, I'm giving the names of my software to all my previous or current pets. So since I own squirrels, cats, dogs, and a horse, even a horse, so I have plenty of names to pick on. 6 cats, that's the drill. Anyway, that's Milo. And let's drop the bomb. We are in a JavaScript conference, and that's why I wrote Milo in Rust. Why not? Right? I mean, that's a good thing, right? Thank you very much. So let's drop the bomb right away. Milo is written in Rust. Why is that? Why not? The thing is that, first of all, the language is performant enough, and I will show you how it's performant enough, and flexible to allow a very, very innovative approach on how to write these parsers. Fun fact, I didn't know Rust before writing Milo. I started completely fresh on Rust, and I basically put an experiment on myself and on the language, and say, how far can I go without having prior knowledge of the language? And the reason for that is that you can see as very silly attempt to open the door for Rust in Node Core, right? And I want to see, okay, how is it hard for a prospect Node contributor that doesn't know C++ and wants to contribute in the native part of Node to be involved. Let's see if it's doable, if it's possible, how hard it's going to be, and so forth. Anyway, I'm not here to start a new language flame. I'm not a troll, so be gentle. It's just an attempt, just an experiment. Also another thing, as I said much earlier today, I love HTTP. It's a piece of art. Milo is completely based on similar API and the exact same architecture of llhttp. I kept most of it, so kudos to Fedor. If you watch me, you're an evil genius, but kudos to you, just saying. And I'm still writing a state machine, but thanks to the flexibility of Rust, I could compress 80 original states to just 32. Much easier. And I could also, instead of having a type-based chain-styled declaration of states, I can use the declarative approach for states definition, and within those states, you don't have any code restriction. Because what I forgot to tell you is that in llhttp, you can use a subset of TypeScript when it's very specific function set. In Milo, you can use whatever you want, which is valid Rust code. Technically speaking, you could validate another name against a remote source if you want, and you're very evil. Nobody prevents you to do that. You can. Now, are you wondering, all these things looks amazing. Paolo, how do you do that? There must be some problem, right? Well, actually, it's not that hard. Everything is in the macros. Sorry for the bad pun there, but everything is in the macros that Rust provides. Because the Rust macro system is overly powerful. Basically, to give you the general idea, is like that you evaluating Rust code at compile time, which basically parses your Rust code and generates new Rust code. Sorry for the repetition, but I have no other way to say that. And basically, you can, at compile time, you can evaluate it and do really anything you want. For instance, since I'm evil enough and lazy, I was loading the list of valid HTTP method from my YAML file and generate Rust code out of it, just doing cargo build. You can do that. That's absolutely allowed. And as long as you return new Rust code, which is valid Rust code, you can do anything you want. Done. It's easy. And also another very good thing is that there is a very easy way with a single tool to debug this thing. So how to debug? What is the macro expansion? What will my code will look like when I actually expand the macro and then I actually compile it? There is a tool which is called cargo expand. I mean, very lack of fantasy, but it's very easy to see what is the final output of your code. And let's prove it. Example are worth more than 1,000 words, right? You learn by example. Let's look at this. On the left-hand side, you have a definition of a state in Milo. That's how it looks like. To give you an idea of basically what it does is that when you have finished one chunk of data when received via chunk transfer encoding, which you check that if you have a CRLF sequence, then you set some flags in the parser, and you move to another state of the machine. The otherwise keyword is very nice because basically I can I tell that if you have at least two other characters in your input stream and they do not match the one above, then you fail because you are receiving invalid data. And the last one on line 12 says, if you don't have at least two characters, so you can actually make any decision, suspend the parser. When I say suspend, means that I will return back to the caller, say I consumed so much bytes. You can, when you're ready, send me more, and I will resume my execution and continue my parsing. That's the entire idea of Milo. That's our state definition. Usually states in Milo are this complex, except for a couple of exceptions, but all of those are this simple. Now, when you build Milo and you do execute cargo expand, you get, this is the actual code that gets executed within Milo at runtime. And you can easily see, that's very easy for you to see that. You can easily check what becomes what, because line 1 becomes line 2. So basically, state becomes a function called after the same name with a prefix. For instance, you can easily see that CRLF gets translated to, on line 5 to a byte of /r and a byte of /n. and the flags are the other lines are unchanged. On line 10, you see the otherwise translates to 2 unused characters we don't care about, and you fail it. Otherwise, you return a constant. That's it. So now, raise your hand if you don't see the correspondence between the left-hand side and the right-hand side, please. Without trolling, I mean. You see, right? So they're easy to track from left to right. This is what absolutely not possible in llhttp, and this is awesome for maintainability. Now, you might wonder, what about resources? Milo has a very small footprint. By default, it can behave like llhttp, where we don't copy any data when doing the parsing. We never copy the input buffer for anything. That's by default. Otherwise, there is an option. Actually, there's an opt-in feature. Otherwise, by default, I choose to make something easier for the developer, which basically I only copy the unconsumed part of the input stream eventually. I buffer locally, so usually are a few bytes, and I prepend on the next execution of the parser, so the caller doesn't have to count and remember which pass was actually unconsumed or not. So it's just to make your life easier. This is optional, because so if you aim for performance like we always do in Node, you can disable this one and you're gonna get a performance boost. But it's just convenience at your service if you ever need it. Otherwise, just disable that. This works just fine. And bold, I'm gonna regret this thing very soon, but by definition, I remove support for HTTP 09. I remove support for HTTP 10 because they are just obsoleted. And I only parse strict and compliant HTTP. I don't have any exceptions. I don't have any leniency flags available. I know that I'm going to add them in the future because a lot of people are going to complain. But so far, at the start, Milo doesn't have any of these leniency flags. If you don't follow strict HTTP with the latest RFC, I don't parse you and I don't care. This way, we are secure by default. Thank you. Thank you. Hopefully. Unfortunately, I can already tell you that some hardware is not fixable, so I have to do exception. But so far, I don't care about it. When there comes the problem, I'm going to extend it eventually. If I woke up good that day, whatever. Now, let's see some example, because you all want to see Milo in action. How it works. Let's start from Rust. It's just Rust at the end of the day, right? So how it works. Okay, how many of you know Rust? Raise your hand. Okay. How many of you can look at this code, for the one that don't know Rust, and understand what actually does and how it's supposed to be used? Raise your hand, please. You see, that's pretty easy to use then. That's a very quick DX check. At the end of the day, you create a parser, and you prepare a message to be parsed. You set some callbacks. You can use closures, you can just use a function pointer, whatever you want. At the end of the day, you receive a reference to the parser itself, the current data that you want to, the buffer that contains the argument for that callback, and the size of that data. That's pretty much it. And you can do whatever you want with that. For instance, I chose to log on the screen. What is the position of the parser? What is my current? What is the data? And what are the contents? That's it, right? So there are some additional stuff that you need to do in order to get from the pointer to a string in Rust, but that's pretty understandable. And then you call the parse method. That's pretty much it. You execute cargo run, for instance. And that's the output. So we say that on position 9, we got the status 200. Or for instance, on position 38, there is the start of our body. That was and the body is the callback argument. Done. That's it. Nothing else to say. Now, if you are here, since we heard about Brian's talk, and we talk about Daniel and Yagi's talks, we know that Node.js uses C++. You know that, right? So I have to find a way to make it usable in C++. That would be a problem, right? Actually, it's not. I pretty much got this for free, because the C++ workflow to build Milo to be used in C++ is straightforward. There is a tool released by Mozilla, cbingen, that basically, given a Rust input, generates the header file for you for free. You just need to specify a very small TOML file, very small, I'm talking like 10 lines of like which structure you want to export, if you want to consider something else, the prefix, and so forth. And you have a working H file for C or C++. And then Rust, by default, supports generating a static library. So not a .so file, but a static library, so .a file, which you actually can statically link in any C++ executable. So you don't have to ship it separately. It actually gets bundled inside the executable. And this is supported by Rust out of the box. This is similar for the people who know in Go. Go, by definition, compiles static linked executable. Same idea. Basically, you just add another piece to the executable. And this is the C++ example. Once again, raise your hand if you know C++, except the first row over there because you don't count. OK. For all other people that don't know C++, how hard is to understand this code for you? It's very hard. Raise your hand if it's very hard, or is really unknown pretty much. OK, I will explain you later. That's fine. OK. But I mean, think about this. That's the same idea. If you just ignore all the casting stuff that C++ requires, because unfortunately we cannot get rid of those, at the end of the day, it's just that on line 8 you create a new parser. On line 11 you set up a callback that receives, once again, the data and the size of the data, as is common C++ API. You do something with that, and then you just do Milo parse, and you pass the parser class, basically. At the end of the day, is that, nothing else. Then you compile with a very simple command line, and you basically, so clang++, the standard, the output that you want. You include the libmilo.a file, and you include your source file, and you get an executable. You execute it, you get, once again, the body, the same output. That's it. That's pretty much it. But I want to support SmartOS. We haven't done yet, unfortunately. So when I originally presented Milo in the Node Column Summit in Bilbao, I was proposing this linking approach. But they told me that, first of all, other collaboration objectives say, is hard for, we want to have, first of all, the Rust toolchain in our build machine, because it's easier than to include a static library. And also, we have to double check that every architecture you support, that we support in Node, is supported by Milo or Rust indirectly. Unfortunately, that was not possible because SmartOS has experimental support for Rust, or Rust has experimental support for SmartOS. So it was not really reliable. But we have the WebAssembly. So there is a third way to use Milo. Why not? That's the same software, but I have 3 different API to use it. WebAssembly has always been a first-class citizen in Rust, and there is WASM-bin-gen, which makes very easy to generate a fully working JavaScript module, which internally use WebAssembly, from your Rust code, out of your Rust code, very easily. And as usual, now, since here you're all JavaScript people, I'm not going to ask you how easy it is for you to understand this code, but you see the pattern. You create a parser, you set the callback. In this case, you're trying to optimize performance by using a shared buffer, but it's just WebAssembly semantic. But at the end of the day, it's just you allocate a buffer, and you call a uint array backed by that buffer, and you pass it to the parser. You get a callback. On the callback, you slice it, the original data, so we don't have any copying between JavaScript and WebAssembly, from a position to an ending position, and you do the same. Guess which the output is? This one, for the 3rd time. So you have post, body, whatever. That's the 3rd time. And that's Milo. Now, these are the preliminary performance for native Milo. We are usually match or outperform llhttp sometimes. And what is missing? I just finished the Node.js integration. I'm missing the Node.js integration because I just finished the WebAssembly integration in 11, the HTTP client, as a test environment for WebAssembly. I need to now work on the Node implementation. Also, while here I show you the Milo outperforms llhttp in WebAssembly, in native performance, is always behind it in WebAssembly. So I have to optimize using SIMD, single instruction, multiple, don't remember the D what it stands for, but you can look it up, in WebAssembly to gain performance boost. And also, I want to migrate the llhttp test suite that was originally inherited by HTTP parser, the first parser for Node.js, in order to have consistency. Consider that since llhttp is written in TypeScript Transpile to C, the test suite is written in Markdown Transpile to C. And if you're asking why not, again, why not? Once again, you're genius and evil, Fedor just saying. Last thing, usually I finish my talks with supposedly smart quote from someone else. This time we were Albert Einstein, which says, a person who never made a mistake never tried anything new. So we have to be reckless, like I said in the beginning, to have new ways to do stuff and do something else and experiment and get performance and so forth. That's it. I'm done. Thank you very much, people.
Thank you, Paolo. We do have some time for questions. So does anybody have a question for Paolo?
Yes.
Hello. So the question that I have, so you mentioned that Milo is much more strict than an llhttp ever was and handles much less edge cases. So do you expect to simply drop some of the tests or skip the ones which are handling the cases which you don't expect to cover with Milo at this point?
I'm going to remove them. If there are tests which are relying on basically outdated HTTP implementation, I'm going to just drop it because we don't need those parts. We don't need it anymore. I mean, I can keep it as a reserve and eventually re-enable them later. But for now, I already did, for instance, I already did this with the Node suite. And all over the 3,000 tests in Node, only like 10 were failing for broken HTTP, and I removed them.
Thanks.
Yep.
Got some more over here. This is handy.
This is less of a technical question, but I just was wondering, since you're familiar with HTTP 1.1, 2, and 3, what percentage-ish do you think of the new features in 2 and 3 are based on the ad tech-based business model of, say, Google and Facebook, etc.?
I think a lot. I mean, if you think that HTTP is completely based on Quick that originally started from Google, and even HTTP on Speedy that originally started at Google. So basically, Google is messing with us and we can't do anything about it. That's the gist of it.
It's impressive that you got some performance improvements from an already optimized code base. Do you know why some of the test cases went faster with Milo compared to llhttp?
I compressed the callbacks. Basically, one thing that I'm doing is that the first thing that I do, I'm doing eager parsing. While llhttp was working one character per time, and every time you get a character, there is a callback saying, oh, you know, I got another character for an header. Instead, I wait for the entire header to be finished, and then I send the data all together. So I compress the callbacks, which usually is the pain point because you probably know that every time you cross the boundary between JavaScript C++ or JavaScript WebAssembly, there is a huge performance problem. So I try to minimize the number of those callbacks. So, and I also have planned to do something even more evil after this conference, but stay tuned for that, another talk. Yep.
Got another question here?
I was wondering how easy or hard you found Rust. I saw some code that wasn't idiomatic, but well, I guess when you're starting a language, that's what you do.
That's exactly why, yeah.
I saw that you were using some unsafe. How much unsafe is there in Milo?
Not much of it. Usually, first of all, I haven't wrote idiomatic Rust, probably, and I apologize for that. So if you know Rust, please review my code and be gentle when you review it. But probably I haven't write very idiomatic Rust code. I haven't found Rust very hard because I purposely chose just to start very easy, so start with everything which is shared by any operating system, like for loops. arrays and so forth. And when I needed something else, I just added that little piece that I needed without, for instance, read Rust first, understand how Rust works and so forth. I just added little pieces by end, so it makes my learning curve easier. Also because consider that not only I learned Rust, I also learned how to write a state-based parser and also a HTTP parser. I never wrote any of the three. So I had to learn 3 different things in the same time. And what was the rest part of your question, last part?
How much unsafe?
How much?
Unsafe code.
Oh, unsafe code is not really unsafe code. The only one that I have there is not really unsafe in the sense that, for instance, when I do the typecasting most of the times. So I receive something that I know is, for instance, a parser instance, but I receive as a generic pointer, so I'm obliged to do the unsafe keyword. But I know this actually I'm fine. It's going to be the only one thing I can possibly receive there, at least in WebAssembly. C++ maybe not, but usually it's a developer fault, so I don't care. But for instance, the same for the data that I receive from the input, from the user. I know since I validated earlier, I know it's a valid ASCII, so I can do a string from UTF-8 unchecked. Because I know that I already validated earlier, but the compiler doesn't know, so I have to enforce the unsafe keyword. But that's pretty much it. I don't do anything else.
One thing that is a kind of cultural expectation in Rust is that if you can call your public API and cause some unsafety, some undefined behavior, anything, without using unsafe from the caller, that is a bug in your crate. And that is, like, I suppose that is not necessarily 100% the case in Milo, but I don't know, I can look at it and see how much of that is the case. I
told you, I don't know Rust, so I have made the most horrible mistakes for Rust I see, and I'm not saying that. I mean, I'm pretty sure that when people, think about this, anybody knowing Rust that review my code has stopped and say, why you abused macros so much? Because usually I don't do so many macros, because you can probably spot that I'm a Forben Rubyist, so I'm missing the DSL from Ruby on Rails or Ruby World. And they say, why you abuse the macros? So I'm not really using Rust in the way it's supposed to be, but it actually works. I was able to match the performance without knowing the language somehow, so I might have done right somehow.
Hey, so my question is, you talked about using WebAssembly to make sure that it's supported across platforms. Is that the plan, just to do the WebAssembly only, or was it also to have native code on platforms where it would be easily supported?
No, actually, WebAssembly was not even on my to-do list at the beginning. So when I say, we can't really support SmartOS, I say, okay, let's do WebAssembly. And then I noticed that it actually works pretty fine. And to say the least, it's also opened the doors for something else that I never talked in advance, which means that if you do static linking, of course, you have to do a compile time. If you do via WebAssembly, you can technically switch the parser at runtime as you wish, which means that opens doors for pluggable native modules for Node, but there's something I still have to explore, so we might chat about it, because it might be applicable for your FFI thing. There must be an alternative way to have broader platform support without having to do fully native, because the performance are pretty much the same.
Yeah, let's definitely talk about that.
Yeah, absolutely, whenever you want. Yes.
Okay, thank you. Thank you. I didn't actually initially have a question, but after his question, I have a question. Not Brian's, but this person on my right. So I'm just curious, since you basically use this project to learn Rust, how are you managing your code review process? And especially now that you're in a done state, like, have you actually had someone that you consider like a Rust SME to actually review your code and give you feedback?
Not yet. I got names of people I'm going to stalk in the next few weeks.
Cool.
Pretty
Good
much.
luck. Yeah.
Yep.
Happy to make some recommendations if you
Absolutely,
need
whenever you want. Yep.
Cool. Well, I am going to stop the questions there. I know that there's a lot to...
You can find me outside anytime.
Yeah.
Just ping me.
Because now it is the coffee break time, and we don't want to be standing in front of people for that. So please do join us after the break for more talks.
Thank you
so much to Paolo for everything this morning.